Hi, most excellent rock buds. It's Rock Papa. Hope you guys are doing well. It's springtime and Grammy and I are itching to get out there and look at rocks and visit relatives too. I hope you are also. Today we're going to talk about the eastern United States Foreland Basin. It's also been called the Appalachian Foreland Basin. We're going to find out where it is. We're going to find out what it is. We're going to find out how it formed, and we're going to look at some of the rocks that it produced. So I hope this video will be useful to you. If so, please subscribe. And thank you so much for all my wonderful subscribers. I appreciate you guys so much, and it's so nice to know that some fellow rock buds are out there. I love every one of you. So here we go. The eastern U.S. Foreland Basin. Where is the Foreland Basin? This image should give us a pretty good idea. It's really made of several basins with some high spots in between. In the east, there's the Appalachian Foreland Basin. Up north, there's the Michigan Basin. And to the west is the Illinois Basin. A very important thing to note right now is that this image shows these basins the way they looked in ancient time. That would be around 250 to 300 million years ago, plus or minus. Next question, what is a foreland basin? In this funky picture, you can see a volcanic island chain on the right, or it could be a microcontinent or even a megacontinent. And it is pushing up onto the continent on the left, which is a kind of a gold color. As this continues, the left continent crust is pushed down, ocean water floods in and creates, guess what, a foreland basin. You probably notice that the foreland basin is deep on the right side, which is the volcanic island side, and shallow on the left side, which is the continent side. The foreland basin will receive all the sediments that are eroded from this Himalayan-sized mountain chain on the right. Let's look at how this infilling proceeds over time. In the beginning of weathering, only very fine sediments come off the mountain chain. They drift out and settle in the deep part of the foreland basin, and over time are compacted into a thin layer of very fine, usually black shale. This very fine deep water black shale is the smoking gun that tells geologists that an orogeny is beginning. At the same time that the black shale is coming, over in the shallow part of the foreland basin, we have limey mud that will develop into limestone. By the way, rock buds, orogeny just means a mountain building event where one continent crashes into another, creating great big mountains that erode down into the foreland basin. In what I call stage 2 of the orogeny, you can see that the mountain range on the right has eroded down a good bit. This process has produced a layer of mud that's thicker than the black mud, and this layer can be gray, it can be red, it can be green. It will also harden into shale. In the final stage of erosion of this giant mountain range, huge tons of sand and river conglomerate come down and cover over all the other sediments. This forms a magnificent and gigantic sandy coastal plain with braided rivers running through it. In other words, the sand comes down and forms a coastal plain with a sandy beach and an offshore barrier island, and then more sand comes down and covers that over and creates another beach and barrier island, and so on as the whole package moves to the left. In our case, it would be west. This layer of sand has been washed pretty clean by ocean waves, and it is the smoking gun that tells geologists that the mountain building event, the orogeny, is pretty much over. Hey guys, what I just told you is a simplified version. In actuality, you could have alternating layers of mud and sand and conglomerate, and then more mud, sand, and conglomerate as the climates change and go back and forth. But this simplified version will kind of help you get it into your mind. Here's a kind of summary of what we just looked at, one cycle of an orogeny. It all starts with that thin layer of black shale in the deep part of the foreland basin, and then over in the shallow part with limestone. Next come the major erosion sediments from the mountain, which would be layers of shale, and then the final layer is a layer of sandstone and conglomerate that marks the end of the orogeny. And as I said before, the layers of shale and sand can alternate, and even alternate with limestone as well. The interesting thing about all this is that the Eastern Foreland Basin actually had 3 major orogeny cycles. It all began with the Ordovician Taconic orogeny about 470 million years ago. Then came the Devonian time period Acadian orogeny, and that was succeeded by the Pennsylvanian and Permian time Alleghanian orogeny, when ancient Africa finally crashed into ancient North America and the supercontinent Pangaea was born. Okay, let's pretend it's about 250 million years ago, and these 3 basins are filled with the sediments generally that we have described, and that these areas marked as arches did receive similar sediments, but perhaps not as much because they're high spots back during 250 million years ago. Hey guys, you may be wondering where these high spots came from. Let's have a look at that. All the smashing and crashing of continental collisions pushed these areas up into massive upfolds that are called anticlines, also called arches or domes. Anticlines pushed these areas up into shallow water, and all kinds of calcium-rich reefs developed. Back in those days, it was mostly algae reefs, but I couldn't find a good picture, so I gave you a coral reef. The reefs grew and made the high spots a little higher. Hey rock buds, the funny thing about these arches or anticlines is that today they are actually low spots. Let's see how that happened. Geologically speaking, anticlines erode relatively quickly, mainly because the upfolding process breaks and cracks the rock layers at the top of the anticline, and that lets the processes of weathering and erosion happen more speedily. Bottom line is, what used to be a high spot in ancient times is now a low spot, as you can see the rivers running through this eroded anticline. And notice, my rock buddies, that the oldest rock layers are in the lowest spot of the eroded anticline. In other words, in the middle of the thing. Hey guys, so when you see the word anticline or arch or dome on a geologic map, think about a former high spot that's been eroded and is now a low spot. Okay, so let's pretend it's today, now. That means that these areas that are called arches are actually low spots today. This map that we just looked at doesn't show it, but Nashville, Tennessee is at the bottom of another one of these eroded anticlines / arches. And on some geologic maps, it's called the Nashville Dome. Hey, but we're supposed to be talking about the Foreland Basin, so let's get back on that. As we said before, all these parts of the Eastern Foreland Basin filled up with sediments from the eroding mountains of 3 different orogenies. And that same continental crashing that pushed the arches up into anticlines also pushed these basins into mild synclines, which are downfolds. Geologically speaking, these synclines or downfolds erode much more slowly than anticlines. This is because their middles are downfolded, providing fewer cracks for the processes of erosion and weathering to work. And as you probably have guessed, eroded synclines are now high spots with the youngest rocks in the middle, just opposite to the eroded anticline. Are you confused yet? Hey rock buds, it took me a while to get my mind wrapped around this anticline, syncline thing, and it's more complicated because if you go out to the western states where stratas are younger, anticlines are still high spots and synclines are still low spots, generally speaking.
Yikes.
So I think I'm going to end this session here, and in the next video we'll talk about some of the actual rock layers that were produced in the Foreland Basin. This will give you a chance to maybe look at this video a couple of more times if you want to, and kind of get that under your belt. So thank you so much for watching this, and if this was helpful to you, please subscribe. And this is your Rock Papa saying happy rock hunting to all my wonderful rock buds. Papa out.